Good evening, everyone. I am Goutham again. So today, welcome to a session on debugging OHOS applications. So in this session, you will learn how to make use of inbuilt debugger provided by the Debug IDE. Also, you will learn how to debug your application via HMOS logging framework. So there are two different approaches through which you can debug your like Harmony OS applications. So first, we will move on to the inbuilt debugger section. So in order to debug your app, you need someone. Okay. So in order to debug your app, okay, you need a remote simulator. So I hope you all got your developer ID approved from developer portal, so that you will be able to log into Developer Device Manager and able to launch the simulator. So this will be the first step. The next step would be if you are facing any runtime issues, you have to set breakpoints in your Java code. That I'll show you now. So the third step would be you have to attach the debugger to the process which you want to debug, which means the app which you are running, right? Finally, while debugging, you have to examine variables and evaluate expressions to check those errors. So we will see all these steps how to do in a step-by-step fashion. To access your device manager, so go to Tools, Device Manager. Okay, if you are not logged in, so you have to log in using your developer account. So it will take you to developer portal. Where you can give your credentials and give your consent. So it says you have logged in, and in your Deveco, you will get this window where it will list all the possible simulators. So based on your use case, you choose the valid simulator. Right now, okay, I am choosing TV for now because tablet is invalid. Yeah. So now I'm able to access the remote simulator. Now you move on to the next step. You see, you can start debugging session by setting the breakpoints in your Java code. To set the breakpoints in your Java code, so suppose you are facing some runtime issues, okay? So some behavior may not be happening, right? You know the exact line. So wherever you want to place the breakpoint, for example, line number 36, you see the left margin. I am clicking there. So you see now a red dot appears there. So this is the breakpoint. So when you run your app on the simulator and attach the debugger, so it will automatically pass on this line. And you will be able to inspect the attributes of this button object. So that we will see. The next step is to, after setting the breakpoints, in the toolbar, you will see you have to select the target device from that drop-down menu. So since I have only one device right now, so TV is there, right? So suppose you have multiple devices, you have to choose between your target device. That will be your second step. And you can start debugging by the Deveco provided options. You can see here, there are two different approaches to debug an app, okay? See, the one which I am hovering right now, right? This is a debug option provided with the Deveco. There is also one more option, attaching debugger to the processor. I'll let you know the difference between these two and how to use one, okay? So when you click this debug option, what Deveco does for you is it will build the app, and then it will install the app on the remote device. So two steps, it will first build, then it will install the app, and finally it will attach the debugger, a Java debugger, to the process, that app, okay? So, so suppose you have made some code changes, instead of installing the app by clicking this run icon, you can directly click this debug icon. What it will do, it will build, it will install on the device, and it will attach the debugger. Suppose I am now running the app on this device. Okay. So if you want to attach the debugger to this process, instead of doing all the steps manually, leaving it to the Deveco Studio IDE, you can directly attach to the already installed app using this attach debugger to process. You see when I click this is because at a time you will not be able to run, it may be the ADB instance and the HDC instances are active. So it may get conflict and you will get that pop-up. So I have to kill that. Maybe some other application also using HDC. So this is giving some decrease for the Eclipse. I'll restart Deveco. So as I told, these are the differences between these two options. So if you click this debugger icon, it will do everything for you. It will build, run, and install attach the process. And I'll do this. Okay, now tablet is ready. Let me try out the first option. So now I have selected this option. See, it is building and it is now deploying. Since I have not set any breakpoints, I have set it here. See, it has stopped here. For demonstrating you, I have set this breakpoint, right? So it has stopped here. Okay. We will see this breakpoint and how to debug an issue shortly. So we will proceed with the presentation for now. So I have shown you the first option. Now I have manually ran the application on the device. Suppose if you want to attach the second option to the existing process, you have to click this debugger icon. So you can see now it shows the current running application, and it also has an option called debugger. So you can also select between different types of debuggers. So I'll explain you. So if you select detect automatically, the IDE will choose the best option for you. For example, if you are running Java code, it will automatically only show the Java applications. Okay. So suppose you want to debug native application written in C and C++ code, you can select native only. It will list all the debug native applications here. Similarly, for JavaScript applications, you can select JS only. Or if you want to debug an application which has both Java as well as native or JavaScript and Java, you can select the specific option. It will list the particular running process. So you can directly select that. And when you click OK, okay, I have selected native. It will try to attach. Now see, it says connected. In the debugger window, it says connected to target. So now you can put breakpoints and you can check. For example, on click of this button, I have a button here. On click of this button, if I want to pass the application here in circle component, see, it's getting stopped there. So this is how you can debug your application. We will see a live demo soon, but before that, I'll present you some more points. So in case you are not able to, the Deveco IDE itself is not showing this debug window, you can access it from view, tool windows, debug. So when you click this is a debug window. If it is not automatically opened, you can open it manually from here. So this method too, I have explained you to how start application manually and attach the debugger to Harmony process, and different types of debugger types, depending upon the language which you develop application. So working with the breakpoints, Deveco Studio supports a line breakpoint that passes the execution of your app. As you have seen, I have put the breakpoint. It has stopped at that point. It will not proceed from there, so that you can examine the objects. So what went wrong, and you can determine the causes of runtime errors. You can also examine variables, evaluate expressions. So to add a line breakpoint, as I told you already, so identify the line where you want to lay breakpoint. For example, I want to lay it on line number 51. Click this left gutter. So it will create this red dot. Then launch the app and attach. Most frequently used option is this launching and then attaching. And when you start debugging your app, okay, so in the debug window, which I have shown you, so there are different tools by which you can do different operations. So I'll show you one by one. So there is a variable view, you can see here. So, so when you put a breakpoint, you will get a hold of objects. So using this variable view, you can expand those objects and see what value it holds. You can see the, like if it is a class, you can see the value stored by the variables and methods. Similarly, there is one more icon called step over. Suppose you have put a breakpoint in this line number 49. Okay. So suppose application has stopped here, but you want to move to next line. Okay. In that case, you see here, step over. This is the one, F8. So when you click this icon, it will automatically jump to the next line. Here, there is nothing in 50. It will jump to line number 51. Again, if you click step over, it will jump to the next line, line number 55. Because all these code will belongs to same line. Similarly, if you want to step into some methods, for example, you see here, I have put a breakpoint here, and this is a method. Okay, so if I click this step over, it will jump to next line. Instead, I want to get into this method and understand what went wrong inside that method. Okay, so you have to click this step into F7. If you click this icon, it will jump to this method. So suppose you have jumped into the method, and this method has some 50 lines of code. So you have resolved, you have found what went wrong in line number 10 only, and you want to get out of that method. Okay, you can directly click this step out so that it will come out of that method, and it will stop in the place where the execution, where you went in, it will stop here. Okay, so for that, you have to click step out. And finally, see here I have laid multiple breakpoints. If I want to jump directly from this breakpoint to this breakpoint, another breakpoint, you use this. Here you can see resume program icon. When you click this, it will only stop at those breakpoints. So fine. So now I will present you a live demo to how to debug an issue, runtime issue. So for now, I have designed a sample where in the main ability slice, I have added a dependent layout. So which is in light gray background, it will occupy the entire screen. And I have a button here. Okay. So on click of button, I am going to create a custom component. So this session is not about creating custom component. So this session is just about solving a problem in custom component. A more detailed session on custom component will be done later. Okay, for now in this custom component, I will explain you what I am trying to do. So in order to create a custom component, you have to extend the component class, which we have explained in the previous session. And if you want to draw something, okay, you have to implement this draw task. So what happens when you implement this component or draw task? It will automatically override this onDraw method where you can perform custom drawing operations. And you have to register for that listener, that added task which you have implemented, right? We have to register for that. So in this custom component, what I'm going to do, I am going to just draw a custom circle and I'm going to lay a text on it. So in this draw, you see, I have set some paint properties, drawing a circle. Again, set some properties for text, finally drawing the text. This is what I am doing right now. So here I have purposefully made a runtime error. So to solve that error in this debugging session, so we will see how to solve that. So I have in the main ability slice, I have created a dependent layout. It will occupy the entire screen and there is a button in the center of the screen. On click of the button, I am drawing this circle component. So I'm running this application now. So you see here on click of this draw circle, I'm planning to draw a button. Okay, so draw a circle component. So you can see the code. I am initializing that custom component on click of the button, setting radius, finally adding the component to the dependent layout. So I have also added some logs, like when it has entered the primary constructor. So it has, so inside the primary constructor, this is the, so since I am calling this constructor, you see here, it will directly invoke this constructor and I have init method from all these constructors to initialize some attributes which will be required for drawing, and I'm adding the draw task. Okay, so to custom draw. So once drawing is done, I have mentioned that the view draw is completed. So let's open the log window also. Since the tag is this particular class circle component, I am filtering for this particular circle component. Now I am on click of this button. You see the button is getting clicked. It says creating circle now. Okay, and it has gone inside the primary constructor. Inside primary constructor, here it says initialized paint object, and finally it also says the view draw is completed. But we didn't see any circle getting done. So how we can debug an runtime error like this? So we know on click of button we are facing the issue. So it is better to place the breakpoint in this constructor. We know that something wrong is happening in this custom component only. So I have placed the breakpoint here. Now I am attaching this debugger to already running application. You see, it is already running on the emulator. So I have selected that. So now the debugger also got connected to the running app. So when I click this draw circle, you see the application has now passed execution. It has stopped here exactly in this point. So earlier I explained you, right, in the slide, there are different tools which you can use where there is something called a variable view. So since we have constructed this dependent layout object which is available right now, and we have this represents this main ability slice, and we have a component button. We are see at this point in time we have also constructed the button component. So you can also see you will be able to inspect these objects. So, as I told you, since button is a class, right, it has different input fields and different methods and different values stored for now. So you can see the complete hierarchy of that object. I am trying to show any field which we have set. So we have set here some shape element, actually rectangular shape element that is getting set here. Similarly, you can inspect the values of different layout. So this is how we can at runtime evaluate the objects. Okay, now I'm not in need to evaluate any of these objects. What I'm going to do, I am going to step into this constructor right now. In debug window, I'm clicking step into. See, it has came to the constructor of circle component. Now I want to move on to the next line. So I am going to step over to next line. So since it is calling the super class constructor, right, it will initialize all fields and then only it will come back to that line. I'm just stepping over. So it has came to this flow now. So it will print this log. Now I am stepping over to next line. You will see what has happened wrong inside the init. So in order to get in, I already told if you want to get into this function, right, you have to step into that function. Now I'm going to step into init. So it came here. If view is not visible, you can tell me. I can minimize or do whatever you request. So now I'm going to step over to next line. It will print this log and it checks. So if attribute set is not equal to null, it will go and register for this add draw task. You see here, now the attribute set is null. So it has not registered for the draw task. It directly came out. See, I just stepped over. So if the attribute set is not null, it should have stepped into line number 45. But what happened? Since it is null, it didn't went inside. It came directly to the next line. So the problem is this added draw task is not registered properly. Okay. So I have found the problem now. I am stopping the execution. Let's install this app on emulator again. Since I have made this code change, I just removed this line here and added to the loop outside. So when I click draw circle now, yes, it is drawing the circle. So it has drawn the circle and finally it has drawn the text. So let's move on to the next session. So since while starting the session, I told you there are two different approaches. We have completed one. Now we'll move on to debugging the application using logging framework. So using logging framework, we can put appropriate logs in the appropriate places so that you will come to know the execution flow of the complete app. So the log framework of OHOS is called HighLog. It shows system messages while you debug your app. You see here, I already shown you. So this is the HighLog window at the bottom you see here. I'm hovering now. So when you click this, I'm removing all the filters now. As you can see, the entire system logs are getting printed, and I have kept it in verbose. There is a filter you see here. So you can filter for different types of log levels. So if you keep in verbose, right, it will print all the logs. See, while printing the logs, you can see there is a word called here in this section, which means info logs. If it is D, it is debug logs. Similarly, we have if, error logs, fatal logs, all those different types of logs. So suppose if I filter only for error, you see only the error logs. Okay. Similarly, you can filter for fatal. Since there is no fatal, nothing is there. Info, you can filter only for info, which will print also errors. You can filter for debug logs. Debug will print also info and error. Okay. So if you want to use HighLog to debug your app, make sure your code writes proper log messages and prints the stack trace for exceptions. Okay. To write log messages in your code, use this class. OHOS HighView DFX HighLog class. So log messages can tell you which part of your application failed. Now I will show you how to use this class and what API it offers. Okay. So this HighLog class has 5 different log levels. As I told already, there were debug info, warnings, error, and fatal log levels. So you can call the appropriate methods. You see the method definition here. So this is the format of this method definition. It will take a label, it will take a format, and it will take the string to be printed out. So debug logs normally, when you have to use debug logs, like so this scenario, which we have used debugger, right? Suppose you are facing some runtime errors during development or any errors, exceptions, you can use debug logs. And you have to remove these debug logs before you release your applications to the store. Okay. So info is very similar to debug logs, but it should not expose any sensitive data. It can be left out. Okay. Warnings you can expose, warnings and errors, like in place of exceptions, in case of runtime errors, you will catch them, right? You can expose those errors using these warnings and error log levels. Fatal also you can expose. So I have in these slides, these 3 slides, I have created a wrapper, okay, for this HighLog class to use how to use this HighLog class. So using this wrapper, you just pass the class from which class the class tag it is coming from, the log is coming from, and what message you want to log. So this HighLog.debug which you see is the original API, which will take label log. This will be some format, a predefined format, which you have to construct. I'll give you the sample. And a log format, how you want this tag and message to be printed out. You see here, I have mentioned log format as public with separated by colons, that it has to be printed tag colon message. That format you have to specify. And this label log will include something like this. So it's a predefined constructor which takes what type of log it is. It is an app log. It takes some predefined domain ID and the application tag. Okay, so you will create a HighLog label which you pass at first, then the log format, and this tag is in the specific class where the log is coming from, the message you want to log. So I have created log levels, debug log level, info, warning, and error. So I have shown you already. So since I am debugging right now, I have printed the debug logs using this utility class method debug API. So I have passed this tag from which class it is coming from and the message I want to print. So since I am clicking the button, I'm printing that specific message. So inside a constructor, I have printed some message. Similarly, whatever required message based on your use case, you can print out those logs. So this is how I have already shown you how a log window looks. So note is that I told you already that these debug logs, right, has to be removed. Okay. So if you want to publish your application, so it is better to maintain a Boolean Like if you're debugging, make that boolean as true and control that boolean from one singleton class. And if you're releasing to the app, make that boolean false. And based on that boolean, you control the logs. You can find samples online. Also, you can, I already told you, you can print the exceptions also using the log class. So these are the two different approaches by which you can debug your application, either via inbuilt debugger or via the logging framework.